Looking at radicals or the root symbol is something that's super important in math coming forward. So when we're looking at this, we're going to have to take into account a few things. Now, these terms aren't necessarily things that you're going to have to be familiar with, but they are important to kind of understand that we're looking at radicals in general. When you hear the term radicals, all we're talking about is that root symbol. So a radical sign, which you would typically think of as a square root, but it can be any root. So the index of the radical, so if I had something like this, would be the third root of 8. Okay, the index of the radical just tells us what root we're at. And the radicand itself is the number that we're taking the root of. Then we have the radical sign, which is also our root. Now, when we're dealing with these, oftentimes we're dealing with square roots, which is something times itself gives a number. So the square root of 64 would be 8. 8 times 8 is 64. It's just going backwards from squaring something. So we need to understand a lot of the perfect squares. So 1, 4, 9, 16, 25, 36, 49, and so on. Okay, it's important to know about the first maybe 10 of these because this is going to be very helpful when we're reducing numbers or when we're looking for simplified answers. So when we're reducing a radical, what we're trying to do is make the radicand, the number underneath, as small as possible. Now the way we can do that is to create a perfect square within the radical. Because if I gave something like this, so for instance this one would be the square root of 9 times the square root of 2. Now the square root of 9 times the square root of 2, 2 times 9 is 18, I can actually break radicals up like that. And we know the square root of 9 is equal to 3. So this is actually equal to 3 root 2. We've made the radicand 2 instead of 18. So when we're going through these, oftentimes what we want to do is we want to find a perfect square that we can divide that number by. Okay, and this takes a little bit of practice, but you can find a perfect square in a lot of these numbers to reduce the values down. We always write the perfect square first because we're going to take the square root of that value. Like the perfect square when we were looking at 20 was 4. 4 times 5 is 20. The square root of 4 is 2. For this one's a little bit bigger. We've got the square root of 25 and the square root of 3. The square root of 25 is 5, so we end up with 5 root 3. Now here we've got a number in front. That doesn't really change anything other than we're multiplying by that number at the end. So here we've got actually a very big value, and sometimes it's helpful if you don't see it to just divide by a number that you know this divides by. I know this divides by 2. And even though I haven't put my perfect square first, because 49 is a perfect square, I could rewrite this if I needed to 3 times 7 times root 2. And 3 times 7 is 21, and the root 2 remains. Now finally, this one here, we're going to have negative 5 times root 4 root 3, and negative 5 times 2, because root 4 is 2, is going to give me negative 10 root 3. Now, we can also add and subtract radicals just like any other common value. So when we're doing this, we're looking for like terms. So if I have a bunch of root 2's, I can put a bunch of root 2's together. But I can't put a root 2 with a root 3. We need to have like terms. For this first example, we have a root 2, and a root 2. So if we were to consider this differently, you could think of this as 2x minus 3x plus 4x, where all of my root 2's were x's. Then I can put my like terms together, and it's a little easier to see it. But in this case, I'm going to do 2 minus 3, which is negative 1, plus 4, which is positive 3. So we end with 3 root 2. The next one here, we've got a root 3, but then here we have a root 7. Well, I can't put that root 7 with anything. I can add my root 3's. So we end with 6 root 3 minus 5 root 7. And I'm just going to leave that. There's nothing further that I can do here. I can't put the values together because I don't have like terms. A very common mistake is to try to write something else like 1 negative root 4. Okay, where you've put the numbers together and the roots together. You cannot add or subtract these. They are not like terms. They do not go together. Looking at this next one, we've got a little bit of work to do. But if we think of this a little bit differently, we know the square root of 4 is 2. So we can write that. Now I'm going to simplify this to root 4, root 5, plus root 5, minus 4. We know that that root 5 technically has a 1 in front of it, so we can work with that. We've got 2 plus 2 root 5 plus root 5 minus 4. Now I know I could have put my 2 and my negative 4 together at the start, but I was just doing this to get all of the steps together. So 2 root 5 plus root 5 is going to give me 3 root 5, and then 2 minus 4 is minus 2. If I wrote this as negative 2 plus 3 root 5, that's also correct. Both of these answers are the exact same thing. 3 minus 2 or 2 minus 3 would give me the same thing, just as 3 root 5 minus 2 or negative 2 plus 3 root 5 give me the same thing. Finally, multiplying and dividing radicals. Well, this is just the opposite of this step. Okay, all we're doing when we're reducing is we're breaking it apart. Here, we're just putting it back together. So if I was looking at this, I'm going to have 3 times 5 times 2. Well, 3 times 5 is 15, times 2 would be 30. So all I've done here is just multiplied all of my values together. Now, if I have a coefficient in front, well, what I'm going to do is I'm going to multiply my coefficients in front. So negative 2 times 4 would give me negative 8. And then I'm going to multiply everything under my radical symbol. 3 times 7 gives me 21. So I don't actually have to go any further than this. This is totally fine. Looking at number 3 here, this is just the division. All we're doing is dividing what's inside our radical symbols. So 8 divided by 2 would give me root 4. And then root 4 is obviously 2. Finally, the last one here, in front of our root 2 there, we would have a 1. 1 times 4 is going to be 4, and 2 times 3 would give me 6. And that's all there is to radicals. These are very common in math, especially when we get to trigonometry, so you do need to be comfortable looking at these and kind of rearrange.